So, good morning to one and all students.
Morning, sir.
Good morning, sir.
Very good. I'm going to share my desktop so that you are able to see my presentation. So, is my browser window visible to you, students?
Yes, sir.
Yeah. Okay. Thanks for your response. So, as asked by you, I created Google Classroom, and I am right now compiling the notes for you for the first unit, and for the second unit also I am going to start. So after compilation, I will put the entire notes here, and then the videos, whatever the classes went, that videos also I uploaded in my YouTube channel, and that link also get shared here. Okay, so once it is okay, I will share the link of this classroom. Okay, so after completion of our unit 2 only, we are going for our CAT 1 exam. So it is a oscillation going on. So let's see where we are going to conduct, whether it is in CAMU mode or through email. It is not confirmed. So first we complete our unit number 2, then we discuss the rest of the things. So we go for presentation. So this is what the subject name and the code UDIT 010 ethical hacking and cyber security. This is what the subject name and code. And then today we are going to discuss about the topic called message authentication. That is what we are going to discuss today. So the agenda for today's session are attendance at the start and end, introduction about myself, netiquettes we follow, learning objectives and outcome, recap of previous class, introduction about the topic, explanation, summarization, Q&A feedback if any. So this is what. So as per our session plan, I am going to take the attendance. So students, please unmute your audio so that you are able to mark your presence. Answer your attendance, students. Adarsh, Akash, Jaisurya, Keshwaran.
Present, sir. Sir.
Yeah, okay. Noted, Mageshwaran. Azhar. Azhar.
Present, sir.
Shoaib. Yeah, okay.
Present,
Shoaib.
sir.
Aravind.
Yeah, present, sir. Present.
Aravind. Okay. Saranraj.
Present, sir.
Ranjit from mining.
Present, sir.
Bhavender.
Present, sir.
Antonio.
Present, sir.
Vishnu.
Present, sir.
Ardra.
Present, sir.
Noel.
Present, sir.
Hari. Hari present. Nitish Balaji.
Yes, sir.
Rahavender. Sri Viramani. Shubham.
Sir.
Yogeshwaran.
Present, sir.
Shivaguru.
Present, sir.
Sri Viramani. Yeah, Sri Viramani. Noted. Aniruddha. Krishna Kumar.
Present, sir.
Omkar.
Present, sir.
Ranjit. Danuj.
Present, sir.
Yadudev.
Present, sir.
Aston Khalid.
Present, sir.
Khalid. Yeah, okay. Kamlesh.
Present, sir.
Kamlesh present,
Kamlesh
sir.
present. Yeah, okay. Milan. Suraj.
Present, sir.
Pradeep.
Yes, sir. Yes, sir.
Shobit.
Yes, sir.
Vijay.
Sir, mic issue, sir.
Okay, okay, okay. So I noted the attendance. So 4 to 5 absentees moreover. Let's be finalized at the end. So getting back to our presentation. So introduction about myself and etiquettes to be followed. We discussed so many times. I'm going to jump to the next one. That is learning objectives and outcome. So the objective of studying this unit number 2 is to learn the techniques needed for providing protection and security to our personal data and information resources. And the outcome of this is to apply the different cryptographic operations of cryptographic algorithm. This is what the outcome of studying unit number 2. So next one is recap of our previous session. So we are going to, I'm going to summarize the last class topics. So last class, we started the topic called asymmetric key cryptography. That is what we started. The main purpose of moving from symmetric to asymmetric key cryptography is the key management. The key management is the biggest bottleneck or a flaw in symmetric key cryptography. So that we are moving to the asymmetric key cryptography or public key cryptography in other words. So in this asymmetric, what is the thing we are going to do means here we are having two types of keys, public key and another one is private key. So two keys are used for encryption and decryption process. But that is not a case for symmetry. Only one key is used for encryption and decryption as well. So here the key, that is the public key, is used for encryption and private key is used for decryption. So public key is available everywhere, anywhere. So if anyone wants to share the message to you, then they can take the public key and share the message to you. With the private key, with your having yourself, you are going to open up, that is to decrypt the particular message. So public key is open to all, private key is meant for that particular user. So with the help of the private key only, the user can decrypt the message. It cannot be known to anyone, even though to the sender. Only the receiver side, the private key is confidential. From the sender side, sender private key is confidential. So that is what the biggest advantage of this public key cryptography. So the algorithms here we are following are DSS, DSS algorithm, Elgamal algorithm, and another one that is the most famous RSA algorithm. So three things are here. So amongst this Elgamal and then the second one DSS, the third one RSA is the most preferable algorithm in the cyber security or this cryptographic computer security environment. So why it is because means it started from 1977 till it's adjusting for the input blocks, that is input message blocks, output message blocks, and also to the bit key as well. So still it is followed by the computer security analysis. So this is what the brief summary of the last class. So this class we are going to see about message authentication. So before going into our actual topic, I want to ensure that am I audible to everyone, students? Is there any distortion?
Audible, sir.
Yes. Okay. Thanks for your response. So before getting into our topic, I want to show a small video regarding this message authentication. Then we will get down into the topic. So is the video visible?
Yes, sir.
Okay. Thanks for your response. So this is a small video regarding this message authentication. I hope somewhat you understood, I guess. So I'm hearing some distortion. Is anyone switched on? Vishnu. Oh, okay. No, it is okay. Thanks, Vishnu. So message authentication. Yesterday, class, I told the brief outline about this message authentication. What it is means if you are sending the message to any person, or if you are sending to message myself or myself sending the message to yourself means uh, you or myself want to authenticate the message whether it is the correct message received by myself or not. So for the authentication, there are so many methods are available to authenticate the message. Uh, the popular method is MAC, that is a message authentication code. We are also having HMAC, keyed hash MAC, and also we have the hash functions. That is, MAC is separately available, hash function is separately available. Both are combinedly also available. So this message authentication primarily focus on the confidentiality of the message. That is what the message authentication. In the video that was displayed, but it with the help of algorithm. That is what explained in the video. So I will explain the process. First, I want to show the thing in animated way. That is what I put the video. Now we see the rest of the theoretical concepts. So message authentication is going the following. That is protecting the integrity of message validating the identity of originator, and then non-repetition of origin. So this three only it going to concentrate. That is, it going to give the integrity. Integrity in the sense the entire pattern, whatever the sender sends, the same only you are going to receive. That is what the integrity. Then whether the originator is the authenticated or one, because nowadays we are getting so many fraudulent calls in the name of the famous company. For example, we are calling from Shopclose, we are calling from Amazon, we are calling from Geo. Like that, the call gets started actually. After that, they will tell that you own this much amount, or you own this particular car. Are you having the offer? Like that, it will get started. If you see or search for that particular number, the true caller or anything may be, it shows that there is none of that particular person available, because they purchased the new SIM and then they started this fraudulent event. So the validation of the originator, validating the identity of the originator also done with this message authentication. Whether the originator is the correct authenticator, I mean correct originator, or any fraudulent originator. The third thing is the important thing, that is non-reputation of origin. That is, if the sender frequently sends a message but previously don't have any particular negative records, means that is called as the non-reputation. So if the sender sends a message, for example, you are sending the message to myself, I am sending the message to you, sharing the email content or any document, means there is a no issues, because I am knowing to you, you are knowing myself. So there is no dispute in that. But if in with us any particular person comes and eavesdrop our messages, that is manipulate the messages, means the dispute actually enters into the picture. So that is what the non-reputation of the origin. Then here the methods or the functions used are encryption, it is used, MAC, that is message authentication code is used, then at last hash function. So the next one is combination of this hash and MAC. It is a bit mathematical, so don't worry about that. I'm not going much deeper. If I'm going much deeper, means you will be confused. So I'm not going much deeper. I just going to touch the outline. That's it. So security requirements. So these are the things it will check: disclosure, traffic analysis, masquerade, content modification, sequence modification, timing modification, source reputation, destination reputation. So I already told that sender or receiver having any disputes. Then the entire, whether the entire message gets modified or the part of the message gets modified. That is what the content modification, sequence modification, and also the time modification, in the sense the manipulation in the time of the sender or receiver, anything may be. Then masquerade. Masquerade means eavesdrop. That is peeping to the others' mailbox or others' dashboard, anything maybe. That is what the masquerade. And then disclosure, traffic analysis. So disclosure, it just like a disclaimer notice at the end of the insurance form or banking application, anything maybe. Disclaimer form. Traffic analysis, analyzing the traffic. If it is a very tough traffic, the particular person, that is the intruder, can easily attack your file. Traffic analysis in the sense it is the network traffic, not the regular traffic. Network traffic, that is, we call that as a congestion control in the network, computer network field, congestion control. So traffic congestion is the main thing. For example, if our university results gets available in the website, get released means every one of you get access the website, so that even though if you are having good network speed, you are in good area, you are not able to view your results immediately. The thing is, everyone getting accessing the same website, so the traffic gets increases. So the intruder most of the time uses this traffic. If the then the intruder easily come and attack your data. Data in the sense, data get transferred with the help of the packet. So the attacker can easily attack your packet. That is what the content modification, sequence modification. Because 1 MB of data get transferred into 10 packets to the receiver. So 10 packets received by the receiver correctly means no issue. If there is any missing of one packet, then the receiver cannot receive the entire message. That is what the content modification, sequence modification. If any one of the packet get manipulated or gets manipulated, that is sequence modification. Content modification means n packets, 10 more 10 packets or 10 plus packets gets manipulated. That is what. So this is what the thing. The next one is message encryption. So encryption we seen in the previous cryptography introduction itself. So I'm not going much deeper here. So message authentication code. So here the actual thing comes into the picture, how we are making an authentication. So the authentication can be done with the help of the algorithm called MAC algorithm or MAC algorithm. That is what in the video it is explained. So students, are you able to follow me?
Yes, sir.
Yes, sir.
Okay. Thanks for the response. So MAC, message authentication code. Here, what it is actually going to do means the variable length message, that is the dynamic message, gets converted into static message at first. That is what the thing can be done. Then the second thing it going to be do is it is using a key for encryption, message encryption, it using the key. So first step, it's going to convert the dynamic, that is variable length input to the fixed input at first. After that, it's going to add one key. So if the message is called as M, the key is called as K. After that message, M comes as an input means the next step is M, comma, K. That is what it's going to give. That is what the second point, appended to a message as a signature. So in the video also, that is what explained. So using the encryption, we are providing some encrypted data. So in that encrypted message, additionally, M gets added. That M is called as this MAC. The MAC algorithm provides that M. So after that, it's going to be sent to the destination part, that is the receiver. We tell the flow using the notepad. So at first, sender's message. So this message is always variable length message. So this first step, as per MAC, First step is conversion. That is variable length message to fixed length message. That is what the first step. Then second step, encryption. Encryption, we already know that. So, for example, it is considered as C of M. So, M is the message, C of M. Then, here only the MAC algorithm comes into the picture. So, in the encrypted message, it's going to add the key. So, after that, the message comes or looks like this. So, C, comma, M. So after this, what is the thing the MAC algorithm going to do means, the MAC algorithm going to produce one hash values. Calculating the hash values and attaching the hash values to the C of K comma M. So this is what the part done by the sender. So after that, this can be encrypted message can be transferred to the receiver side. In the receiver side, the back propagation starts. So back propagation in the sense, receiver going to calculate the hash value, then the key, and then the decryption, and then the fixed length message gets converted into variable length message. Then the user can see the message. So this is what explained in the video also. Okay, so clear, pa? I'm not going much deeper into the mathematical formulas at all. So this is what the exercise. That is why I'm explaining. Students, have you understood this?
Yes, sir.
Yeah. Okay. Then receiver performs same computation on message and checks it matches with the MAC, and then provides assurance that message is unaltered and comes from the correct authenticator. So this is what the diagrammatic explanation, message authentication code. So source and then the destination. MAC provides the confidentiality, then can also use for encryption for secrecy. Why we are using this MAC is, we can also go for authentication, we can also go for confidentiality. So authentication is different, confidentiality is different. What is the difference between these two means? Authentication here, not no encryption is required. Just we are going to authenticate whether the originator, that is a sender, is the sender having identity, correct identity or not. That is what the authentication mainly focus on. That is non-reputation, as we discussed earlier. So non-reputation only, authentication going to check. Confidentiality means encryption comes into the picture because we are going to share some sensitive information. That is what the confidentiality. The sender and receiver not going to reveal that particular message. That is what the confidentiality. Using this MAC, we can achieve this authentication and confidentiality as well. That is what the main thing we are using this MAC. If you are going for any message authentication, there are so many message authentication methodology available. Authentication methodology, there are so many methodology available. So in that, the MAC with the MAC algorithm is the best one. So properties, it is many to one function. I'm not going into the mathematical things, so I'm going to skip this. The requirements, knowing the message and MAC is infeasible to find another message with the same MAC. MAC should be uniformly distributed. MAC should be depend equally on all bits of the message. So while you are appending the message using the MAC, this m comma sorry k comma m. The main thing you want to concentrate is ensure that message and MAC gets appended, and then the same message with the key get transferred to the receiver or not. Because without the key, the message and MAC cannot be computed. Then the MAC should be uniformly distributed. Then as per the second point, equally MAC should be on equally depend on all bits. That is what the third thing. So with this, we conclude our message authentication codes and message authentication. So this is what the thing for message authentication. If you are having any queries, means you can ask. I will go for summarization. Okay, your silence, I may take it as a positive note. So no queries at all, I guess. So I'm going for summarization. So today we started with the topic called message authentication. So authenticating the message is the main intent of this message authentication. Authentication means authenticating the originator, that is validating the identity of the originator, then checking the integrity of the message, and the main thing is non-reputation. That is, if any dispute happens previously or done previously by the sender or the receiver, that is what the non-reputation. These three things get checked by this message authentication. So for this message authentication, we are using message authentication codes. In short, MAC. This MAC follows MAC algorithm. So what this algorithm going to do means, first it's going to convert the variable length input message to the fixed length input message, and the second thing, it's going to do the encryption. After that, in the encrypted message, it to add the key. So last step is, after this encryption, adding the key to the message, it's going to add the MAC code, that is message authentication code, to the particular plain text, and it gets converted into the ciphertext. At the end, the reverse process happens to the receiver side, and receiver gets authenticate the message. So this is what the message authentication did actually. So with this, I will conclude our session. At last step, I'm going to take the attendance.